Hello everyone. Today we are going to start with computer vision. Computer vision is unit 5 where you will get 5 marks from this chapter. For data science and computer vision, data science previously we had completed, that is for 5 marks. And in the same way for computer vision also 5 marks. So in the computer vision, on which topics you have to concentrate mostly? Here also children, please don't get confused. Both the chapters, data science and computer vision, they are only for 5 marks. In the data science also, I said you have to concentrate only on 2 topics. Here you have to concentrate only few topics to get full 5 on full. So what is that? First, you have to know the definition of computer vision, applications of computer vision, classification, localization, object detection, instant segmentation, pixel, resolution, pixel values, what is digital image, binary images, grayscale images, RGB colored images, image features. All these are the definitions, children. Just if you know the definitions of these concepts, then you can score full 5 on full 5. So now we will see the complete what we will see in the we will see the explanation of these topics, children, right? So first we will start with the definition of computer vision, right? The definition of computer vision you had learned already in the domains of computer vision. The same definition you can write over here, children. Right, the definition of computer vision, you can write the definition which you have learned in the domains of artificial intelligence, or this definition also you can write, children. What is the definition? The computer vision is a domain of AI, enables machines to see through images or visual data, process and analyze them on the basis of algorithms and methods in order to analyze actual phenomenon with images. Like as a humans, we are able to recognize any images. How we are able to recognize the images? By using our eyes. In the same way here, the machines are also able to recognize the images with by the help of computer vision. So for the computer vision, what type of data we have to give? We have to give the data in the form of images or visual data. Once we are giving that, it will process, it will analyze, and it will, depending upon the algorithm, it will find out what type of image is that, and it will give the output to us, right? So this is the definition of computer vision. They may ask you define computer vision, then you can write this definition, children. And next, applications of computer vision, as you had seen in the domains of AI, when I'm explaining computer vision in the first chapter, we had seen few applications of computer vision like self-driving cars. That also you can write here. So the first one is what applications of computer vision, facial recognition. When they were asking you to define applications of computer vision, any two, and for 2 marks, you have to explain with clear explanation, children. Mostly they will ask for the objective type questions only, these applications of computer vision. But still, if they were asking, you should be in a position to explain very clearly the applications of computer vision. The first application is what? Facial recognition. As we are seeing in our mobile phones and in the smart, like in the smart homes, smart cities, computer vision plays a vital role in making the home smarter. Security being the most important application involves use of what? Computer vision. Has facial recognition for face locks and what guest recognition or log maintenance of the visitors. It also finds its application in schools for an attendance system based on facial recognition of what? Students, right? So this is the first application of computer vision, that is facial recognition. The second one is what? Face filters. The modern day apps like Instagram and what? The next application of computer vision is what? Face filters. In the modern days, like Instagram and Snapchat have a lot of features based on the usage of computer vision. The application of face filters where we are seeing in our Snapchat, right? One among them, though the camera, the machine or the algorithm is able to identify the facial dynamics of the person and applies the face filter selected to us. We are like most of us are using the Snapchat filters for that purpose. Google search by image, that is once you upload any image in the Google and if you ask anything about related to that image, you will get the details. Not only that, the Google Lens where we can scan the image and we can get the details of that image. Mostly the students in their education, they were using this Google Lens for reading. Suppose a child is not able to read, right? A Telugu or Hindi language where they are having the difficulty, they can scan through the Google Lens, and once they click on translate, what it will do, it will translate to our own language, and it will make our reading very easy, right? Next one is what? Computer vision in retail. Most of the shopping malls, like in the foreign or like here also, we are going to get what they are going to do is they are going to see the movement of the customers. Here we are seeing in the stores, the movement of the customers can be like we are having the CCTV cameras. Not only that, in some shopping malls, whatever you pick, once you are entering into the shopping mall, you have to sign, you have to visit their website, and you have to give all your details. Once you enter into the store, whatever the grocery items or anything you are buying, once you are out of the store, automatically the amount will be deducted from your account. No need to wait near the billing counter. No need to waste your time. In that way, they were using this computer vision in retail. Not only that, to find out the expiry date of the product. Suppose the product expiry date is going to complete, then what will happen? The alert will go to the store manager stating that the expiry date of the product is going to finish. So the store manager will remove that items, or he will bring that items to the front. This is another application of computer vision. And self-driving cars, everyone knows, and we are using this computer vision in medical imaging, like what 3D models now, and for the 2D scan images, right? Next is what? Google Translate app, I said, has a Google Lens. You can scan and you can convert that into the another thing, right? So here has a humans, I said we are using our eyes to visualize anything. In the same way here, the machines are using what? The sensors to identify any items, right? The most important thing is, children, from this you will get 2 marks. Definitely 2 marks question will be from this basic concepts of computer vision. Or you may get in the objective, children. 2 marks question from this chapter also, 1 and 3 marks objective type questions you will get from this chapter, children. The first one is what? Here, basic concepts of computer vision. You have to concentrate on these 4, children. So 2 are like single object and multiple objects. What comes under single object is classification. Classification plus localization, object detection, instant segmentation. So we will see what is classification. First, classification is nothing but once we are giving an image to the machine to identify, what it will do. First, it will classify, and it will say, okay, this belongs to what kind of image. What in the image, what kind of picture they are going to see, right? So first it will classify. That is what? A classification, classifying. The task of classification when it relates to images generally refers to what? Assigning. It will assign a label to the image. Like now here, what image is this? This is a cat image. So what it will do, it will assign a label to this image in the classification. Next, localization means what? As it is a single object again, what it will do in the localization, in the classification, it had identified the image and it has labeled as it has what? Whole image, it will give a label, it has a cat. In the localization, what it will do, it will refer to the same image, but it will usually denoted by the output of some form of bounding box around the object. It will identify the cat image in that object. Only to that cat image, it will draw a border. That is called as what? Localization, right? And next, what is that? Object detection. Now you see, object detection comes under multiple objects, I said. In classification and localization comes under single object, children. Once again, I am repeating, classification means it will identify the image and it will label that. In the localization, what it will do, it will specify the means what it belongs to which, where it is, that cat is in which place, right? So it will draw a border to the entire image of the cat, and it will keep, okay, cat image is placed over there in this entire image. In that way, it will identify and it will keep. Next one is what? Object detection. Has object detection comes under what? Multiple objects. What it will do here? Here we are having multiple objects. So here, like what? So what all the multiple objects we are having? Duck, we are having cat, we are having dog, we are having So for all this, what it will do, it will draw a boxes. Finding instances of real world objects such as faces, it will identify the real world, means the images in that what the entire image, it will identify the real world objects. Suppose now we are having a scenery image, in that you are having different types of images. Scenery, it will leave. It will identify only the image. Suppose in that scenery, we are having mountains and a girl and a boy and a bicycle. A boy was sitting and a beach was there. They will remove the beach. They will remove all the mountains, all those things. In the object detection, it will identify only the real world objects. Means it will draw a box to the boy, to the bicycle, right, to the faces. For that, it will draw a box, right, and it will create an algorithms to recognize that. Means it will recognize the instances of an object depending upon the patterns and the algorithms, and it will draw a box to that. That is what object detection means. It will detect the real world objects in an image. That is called as object detection, children. It will recognize by using different algorithms, and it will draw a box to that real world objects. Next is what? Instance segmentation. This instance segmentation means what here? Now it has identified, and for each image there will be a pixel. Means what? It will label, like how it will label? Duck, cat, dog. Okay, it will label on the basis of what? Pixels. Given, see here, it is a process of detecting instances of the objects. It will detect the instance of that object. It will categorize them into each separate part, and it will label them here. Once again, I am repeating, children, in the object detection, it will detect the real world objects. In the instance segmentation, the objects which it has detected, it will give a label to them, right? It will draw instances for that, and it will label them. That is called as what? Instance segmentation. Single objects is what? Classification, localization. Classification means what? In entire image, it will identify the object. That is what? A cat. And it will label it as a cat image. And in the localization, where that cat is placed in an entire image, it will draw a box to that, and it will keep. That is what? Single object. In object detection, it will identify only the real world objects, and it will draw, like it will keep in an instance of that in the instance segmentation, and it will give name for each object. That will happen in the instance segmentation. These four concepts compulsory, you will get 2 marks question, children. They will ask define classification or define classification, localization, define object detection, define instance segmentation. Just you have to write these definitions, children. Then you can get 2 out of 2, right? And next, pixel. How do computers handle images, right? How do they display images on the screen? How do computers store images? What are images made of? Images are made up of what? Pixels. The word pixel means what? A element, a small element in a picture, we will call it as what? Pixels. Every photograph is in the form of what? The digital form. It is made up of what? Pixels. The smallest information which is present in the picture is called as what? Pixel. And all the digital images which we are having are what? 2D images. We are not having any 3D digital images, children. Whatever we are seeing is a 2D. And next one is what? Resolution. Resolution means what? The quality of an image, right? Suppose you are watching your movie in a 42 inches. What? The resolution of that, the quality of that video will be very low. If the same movie you are watching in a 75 inches TV, what will happen? The clarity of that movie will increase. Why? There the resolution is more. So here, resolution means what? The number of pixels in an image is called as resolution. They will ask you definition of pixel. The smallest part in an image is called as pixel, and all the what? The number of pixels in an image is called as what? Resolution. And you have to write this also. Here, the resolution is what? Of a monitor is what? For example, The resolution of a monitor is what? 1280 into 1024, right? So, and this means there are 1280 pixels from one side to the other and 1024 from top to bottom. This you will write for the definition of resolution. There is a scope for asking 2 marks. Next is what? Pixel value, children. The pixel values will start from 0 to 255, right? Each pixel that represents an image, each pixel will have a value. The number is stored as an 8-bit integer giving a range of possible values from 0 to 255. The pixel value starts from, they may ask you in the objective type question, the pixel value starts from 0 to 255. Okay, typically 0 is no color, it is black. 220, 255 means what? Full color or white. For colored images, we have 3 values. That is what? RGB. Okay, RGB is nothing but it has 3 values. The pixel value will start from where? 0 to 255. 0 is no color or black, or white is what? Full color, or 255 is full color or white. What is a digital image? As we said that digital image is what? What? In each picture we will have pixels. Digital image is defined as a 2-dimensional function. I said all the digital images are 2D dimensional. We are not having any 3D digital images, right? 2D function, the dimensional function f of x comma y, where x and y are spatial coordinates and the amplitude of f at any pair of coordinates. X comma y is called the intensity of that image at that point. So if they're asking you what is a digital image, you will write it is defined as a 2-dimensional function f of x comma y. You will write x and y are the spatial coordinates and f is the amplitude of these coordinates. Okay. When x comma y and amplitude values of f are finite, we call it a digital image. When the amplitude values of f are finite, then we'll call it as what? Digital image. Therefore, an image can be defined by a 2-dimensional array, specifically arranged in what? Rows and columns. Very important question, children. Binary images. Last time also they asked monochrome. They asked where the binary image, as its name suggests, contain only 2 pixel elements, that is 0 and 1. The image, the pixel elements 0 and 1, the binary image is called as what? If the values are pixel 0 and 1, that is called as what? Binary image, right? So here 0 means what? Black, and 1 is what? White. Same. If the pixel value of an image is 0 and 1, that is called as what? Binary image or monochrome, children. Last time they asked, so please concentrate on this. Once again, I am repeating. If the binary image value is 0 and 1, that is called as what? If the pixel value of an image is 0 and 1, that is called as binary image, and it is also known as what? Monochrome. Right. Next is what? Grayscale images, children. Very important. This also. Grayscale images, binary images means the values, the pixel value is 0 and 1. When it comes to grayscale images, the range of shades of gray without apparent color. Here means what? Completely the shade will be what? Gray, right? The darkest possible shade is what? Light black, and which is the total absence of color or 0 value of pixel. The lightest possible shade is what? White, which is a total presence of color or 255. Here what? The darkest possible in the grayscale images is what, children? Black, and the lightest possible shade is what? White. Okay, mostly then that images will come under what? Grayscale images. Next is what? RGB images. Very important. Red, green, blue. Okay, all other colors were formed with the help of this red, green, and blue, children. Okay, here if you are keeping the value as the value, I said it starts from pixel value starts from 0 to 255. If it is 0 and 255, that is called as what? An image, right? If it is 0, I had said what is next? What is this binary image? If the value is 0 and 1, that is called as binary image. If the black is more in the image and the white is very less, that is called as grayscale images. Okay, RGB means red, green, blue. If the value is suppose 156 and comma 222, then it will form one other color. Where the values are changing, then we will get different multiple colors that comes from the red, green, blue, right? And last topic in this is what? Image features. Generally, features means what we will say, like information about that. Here also, it will tell the feature is a piece of information about that image. Means what? Suppose now we are having an image. What is the information about that image? In the image, we are having what edges we are having, right? And what we are having, curves we are having. The building is having curves, boundaries, right? And the point, specific structure, the structure of the building, right? All this comes under the features of the image. Mostly you in this chapter, you have to concentrate on the definition of computer vision, applications of computer vision, and next what? Uh, Localization. I said now object detection, localization, right? And that 4 children. Once again, I will repeat: single object, multiple objects, classification, localization, object detection, and instant segmentation. This you have to concentrate where there is a score for 2 marks. And next is what? Pixel. What is a pixel? Definition of that. What is resolution definition? What is digital image? Digital image is also called as what? Again, what is digital image? And binary image is also called as what? Monochrome. And the grayscale images, RGB images, and image features. If you are perfect with these concepts, then you can get 5 out of 5. Right, children? See, now we had completed totally 4 chapters for 3 days, children. Okay. So how many marks we had covered? First chapter is for 11 marks. Second chapter is for 13, where is 24. And this chapter is, these 2 chapters, data science and computers vision together is 10 marks. Means what? Totally 34 marks we had covered as of now. If you are perfect with these 4 chapters, children, you can score 34 out of 34, right? In the next class, we will continue with natural language processing, which is for 11 marks, children. So thank you. Please, I am going to share today in the description the sample question papers drive link also. I want everyone to solve these 4 chapters, sample questions from that sample question papers, children. Then you will get a confidence that you are perfect with these chapters. Thank you, children, once again.